Hello, this is Charles Gardner presenting PCA Embed Random Forest, which was created with the help of Dr. Danlow. PCA Embed Random Forest seeks to improve the classification precision of the random forest algorithm for highly imbalanced datasets. The dataset being used in this study is a financial fraud dataset containing 6.3 million transactions with 8,200 fraudulent transactions. The PCA Embed Random Forest was tested using 50 optimized models for F1 score and 20 optimized models for precision. These models produced a fairly similar F1 score to traditional random forest with a slightly lower average F1 score, but produced much higher precisions than the traditional random forest, making it useful for some applications where you might want to have a high precision over a high recall. This would mean that you want your model to be correct when it says something's a financial fraud, which could be important if the results of something being identified financial fraud are severe, such as maybe an account being frozen. You want to be correct in that situation, and so it would be useful for those sorts of models. This improvement is accomplished by embedding a PCA model within each decision tree of a random forest. The PCA model is created using a random selection of features from our feature set, and then PCA is used on those features to reduce them into one new feature containing patterns from each of the features which fed into it. This allows random forests to make linear separations on that new feature, which address patterns from multiple features, something that it previously couldn't do, as it only makes linear separations on a singular feature when making a split in a decision tree. Using this new information, Random Forest was able to produce higher precision models, and as a result could be useful in certain situations, but not all situations. This approach is good for when you want a model with high precision above all else, which is useful in some problems. So, thank you for listening.